Oh, there it is. All right. Mute that. What else do I need? I think I forgot to upload files last time. I do think I remember to do the YouTube video though. So we'll just upload files from last class now to make sure that I did it. Let's see. No, looks like I got it. Good morning, everybody. It's 11:30, but we'll just give everybody a few seconds. For anybody who's in the chat, if you've got some homework questions, you can throw them out there. Any other questions, you can throw them out there. I'll take a look. If you checked the Discord, you might have seen some stuff posted about the homework. There's a small output mistake in there. I did mention that last class, so you probably knew about it. Maybe you didn't. Okay, let's fix this. Today we're going to have a better day than we did on Monday. I'm excited. Today is our last day going over pointers in dynamic memory allocation. Though we'll have plenty of it in the future. You'll see me do it plenty of times. And today we might start virtuals if we get there. So I think I'll just keep doing this from now on. I like to start off the class just quickly reviewing kind of the notes that we talked about last time. And the make file, I messed up, but I can correct it today. And you're not required to know make files for the test or anything in this class, so you don't even have to worry about it. Make files will come up more, I think, in operating systems. But just as long as you know what they are and that we can compile code by using them, then you're good enough for this course. So that stuff, let me make this bigger. So we did kind of talk about this stuff. Let's see, this was from last class, right? Yeah, this was from last class. Right, so last class we talked about the arrow operator. Oh, here we got some questions, I'm sorry. Seabay says, what should we do for the input? Should we use a loop? Will the user only enter one line of input without pressing the enter key? I'll give you some code for that right now. Now, there's two different kinds of input that go on here. There's the initial input when you're entering the code, right? So, and I'll make this text bigger in just 1 second. Let me just type out this stuff. And we'll do a vector as well. So the initial line of input is going to be terminated by a 0, right? So green, it doesn't have to be a color, right? So I said it could be like zoop, blue, black, or whatever. And then there's a 0 that terminates that. And so the input could literally look kind of like this, right? Where the user enters green and then hits enter, and then zoop blue and then hits enter and then hits black. And it's just going to wait until it finally sees this 0. And once it sees this 0, then the input is good to go, right? And you can make the game. But then when it comes to user input, it's actually much easier than looking for a 0. So we know that how long the input is going to be, so you can actually force the user to input that many things. And so the way you do that, for example, and I'll give you some of this code right now. I won't save it to Web Campus, so maybe take a screenshot or something. But you're probably going to have a vector string, and we'll call it user input. And let's say we know that our int length, right, code length, is equal to 5 in this case. And so what you'll probably do is you'll say something like user input dot resize to the code length. So I may have mentioned this kind of in my hints, right? But what does this do? This makes 5 spots in the array, or makes 5 spots in the vector. Does that make sense? So this basically makes an array of size 5, in which you just resize this vector to be the code length. And then whenever you're ready, you just say for int I is equal to 0, I is less than. Now you could do code length here, or you could do user input dot size, right? I plus plus. So we know that this will loop 5 times. You just say cin to the user input at I. So this is going to loop exactly 5 times, and cin will break on... cin doesn't work on spaces, right? And cin also doesn't work on end lines. And so if you have this code, it's going to force the user to input at least 5 things. Does that make sense? So let me just make sure. Right, so Cbay, the user could enter 1 line of code, or, because if they enter 1 line with 4 spaces, this cin will grab all 5 of those words. But if they do this thing where they enter 1 and then hit enter, enter, and then enter another one and hit enter, enter, this for loop is still going to make sure that they enter 5 things. Yeah, so I would definitely recommend doing this. Take a screenshot now before it goes away, if that's something that you care about. And I'm going to read the next question. Peter says, if the IDE can tell us we're missing a semicolon, why can't it just add it automatically? I'm not sure. Maybe there's an option to do that. You know, maybe you could get hired at Microsoft to do the G++ compiler, which will do that for you. From the way I see it, to be a good coder, we got to know how to build it entirely, even if we make mistakes. The IDE will help us, right? If we type something like user input, or IntelliSense will help us. You can see here, it's like, is this what you mean? And this helps us not make a mistake, right? If I put a lowercase I there, then I made a mistake, obviously. But yeah, I mean, I honestly don't agree with an IDE like making changes to your code, because maybe the change it makes is not what you wanted. So that's all I'll say about that. And then we see here, languages like Swift allow you to use either semicolon or nothing at all to end a line. So yeah, just use Swift. Just go to a school where we learn Swift instead of C++. Cbay, you're welcome. And we're good to go. So throw more questions in there if you need. I'm just come back here to review some of our notes. So recall that we did the arrow, right? And so the arrow is the exact same thing as dereferencing a pointer and then using the dot operator on it. This arrow is much nicer. And the reason it's incorporated is because people, when they first made C++ and they were using pointers with class objects, they found that they were doing this a lot. dereference, put it in parentheses, and then use the dot operator. So they said, let's put an operator in here for this. And so we've got our arrow operator. We'll be using that more today. And the way that I'm showing you how to use it is with this, the keyword, but I'll also show you how to use it in main. And so I kind of gave you an example here, right? Here we've got a student pointer, and so we can either access the name using the arrow, or we can do this whole dereference dot thing. They're the exact same. We talked about new, right? We should know what new does, except if we're going to do an array, we include these brackets, and we got to put some integer inside there. So here's an example in which we allocate an array of 10 using new. Delete, right? We learned about this, which is the same as regular delete, except this one's got the brackets. And this will delete a whole array. Okay, so you should not call this on a just a single pointer. That's not an array. It should always be called on array pointers. So anything that was allocated like this needs to be called with a delete like this. So I gave you some example here. We talked about the shallow copy and the deep copy. Today we'll go over more of that in the example code as we're finishing it up. Right, but recall that with pointers, a shallow copy is when we just copy the address, in which we alias two pointers, and the pointers are pointing to the exact same location in memory. So if you change one of those variables, the other one is going to change too. And in general, that's bad practice. A deep copy means that we make sure that this variable has its own memory first, and then we dereference those arrays, or we dereference those addresses to make sure that we copy the value and not the array. Or not the address. I'm sorry, there's too many A words going on in my mouth today, but I'll get warmed up here. Once again, make sure that Y has its own address, its own memory location first, and then we dereference them to copy the value and not the address. Arrays are the exact same, right? Except shallow copy looks exactly the same, but for the deep copy, we need to allocate the actual array. And we're going to have fun with this today as we're finishing up our dynamic array. And then you got to copy those elements one by one. Super tedious, I know, but don't you forget it. And then we talked about the rule of three, so we'll kind of review that today. But whenever we're making a class that has a pointer in it, we need to make sure that that class has three things. One of those is a destructor. And the destructor is used to deallocate the memory at the end. You know, when that object goes out of scope, we're going to want to deallocate that memory so there's no memory leaks. The copy constructor, in which there's a constructor that takes in an object of the same class to make an object that is a copy of the parameter object. And so when we do this copy constructor, we need to make sure that we're allocating new memory and not doing any shallow copies. We're doing only deep copies. The assignment operator, we'll cover operator overloading later. I've decided today that I'll show you how this works anyway, because I don't think it can hurt. It will also help me show you why we use that keyword. And so you don't have to memorize this today, but I'd appreciate you paying attention because it will be helpful. And so when we do this assignment operator overload, we're making sure that we're doing deep copies and not shallow copies. Helps us fix these things. Here's an example of using a copy constructor. Here's an example of using an assignment operator. Let me ask you this. It's not a hard question, and I know that I know it might be a trivial question. I don't think you guys are stupid by any means. I like to repeat myself a lot. So, and since you don't know exactly how assignment operators work, I'm just going to ask you this, and you can take a guess. But if we look at our code from last class, and let's do that, I'm going to kind of copy it over. I did finish it up on my own. But I kept track of everything that we did. So the first thing I need to do is bring a string. We probably don't need this vector anymore because we're making our own vector class. And we're making a dynamic array class. Now there's a few things I've added. For one, I added these delete functions, okay? So we'll code these up today, and it'll be fun practice for us to do dynamic memory acrobatics. But we had this insert function that we didn't do. We had this void print array function that we didn't do. But we did do the destructor, right? And we did do the copy constructor. And we also did this constructor and this constructor. So let me go ahead and bring in everything that we did last class. Let me see if I can zoom out just a little bit. So this is everything we did last class, right? The regular constructor, and then we did this. This is kind of a copy constructor, right? But instead of taking an object, it takes a size in a pointer array, right? And we talked about doing a deep copy here. We talked about the destructor, where we should delete that array, that pointer. And then we did the copy constructor. That was the last thing that we did, which looks exactly like the other constructor up here. And I kept using this in the arrow. So now to this question that I've been leading up to. We're going to do this operator today, okay? And notice that this operator, it looks like a function. And so up until this point in time, we're just going to consider it as a function. So first question is, notice that this is an operator, okay? This is an operator, and it's the equals operator. And it's a void type. Do you guys know of any operators? And I know that you've used them before that do return something that aren't void. It's okay if you don't know, but this might help us, solidify our understanding. And so this equals operator is not going to return anything, but there are operators out there that do. And if you know it, throw it out there, and I'll come back to it to see if anyone takes the right guess. But then the next thing I'm going to do is I'm going to make an array here. So yeah, actually Seabane nails it. Equals does return a value, right? That's very good, right? This is going to look kind of weird, right? But you can say bool val is equal to, 1 equals 1. So equals either returns true or false, right? So that is an example of an operator that is returning a value. So very good. Why is it not like this? Probably because of this. Just to prove to you that this will compile. Yeah, there you go. And then Red Rosenrot says plus. It might. I don't think it does. It might. But I'm thinking more along the lines of plus and minus. So you guys may know that those return values, right? In the prefix and the postfix kind of things. Like I said, we'll cover this when we get to operator overloading, but just as long as we know that some operators return values and some don't. And so now let's say I have a dynamic array A, and I have a dynamic array B. And I had asked this before, right? In this case, B is the this object, right? And A is the copy parameter. So notice that this operator is part of the object, right? It's a member function of the class. And so when I say A equals B, can anyone tell me, and just looking up here in the operator, you can see that it takes a parameter copy of A and B. Which one is the this object and which one is the copy object? It might be sort of trivial question, but just to make sure everyone knows what's going on here. Which one of these will be this and which one of these will be copy? And then we'll kind of code it up here. See? Okay. So I don't blame you. And so think of it like this. It's kind of like we're doing A operator equals B. So now if I put it that way, does anyone want to change their answer in which, notice that A is what's invoking the equal sign. A is invoking this equals, and B is passed as the parameter, right? So, in fact, A is the this object, and B is the copy, right? Yes. So just so you understand, and look, this even looks like it'll compile. We can even call this operator, so that's totally fine. But these two things are doing the same thing, right? And just like here, this is B invoking, this is B calling the constructor and passing A as the parameter. So in this case, it's backwards, right? B is this, and A is the copy, right? And in this case, A is this, and B is the copy. So no worries, I appreciate the participation always. And so that's all. We're going to talk about the actual operator part of this, and you can erase it from your brain, everything we talked about here, but we're going to code this up. And we're going to talk about doing deep and shallow copies. And I'll show you why we use this, right? And so the last thing we talked about last class was this is a pointer to the address of the object that called the function, right? And so when I'm asking you this question, which one is this and which one is copy, this is referring to A, and this is the pointer to this object A. Whoops. So let's go ahead and code up that, let's code up this guy down here. And whenever you see this, what does it mean? You need to let it know what scope it's in, right? So there we go. And so there's nothing... I want you guys to recall this. Int x is a value, and this is a legal C++ operation, isn't it? We are allowed to assign the value of x to x. Now, is there any point in doing this? No, there isn't. And so just like that, we can say, just like we can say here, we can say A equals A. And so we can kind of save ourselves a bit of work, right? Does anyone have any ideas on how we could check to see if the objects are the same within this function? And I'll give you a few hints. We have this, and we have copy, right? So using these two things, does anyone have any ideas on how we can check to see if they're the same object? And so I'll even put this here. We're going to do an if check, and then we'll do an else. And I guess we'll take it one step at a time. I'll give you just a few more seconds. Like I said, this is all new. So if this returns the address of the current object, right? So in this case, if we have A equals A, then this is some hex address, right? Let's just say it's like that. Yes! Yes, Red Rose nails it, right? So how do we check the address of A, right? How do we check the address of this? We have an operator for that, right? And so then we might say the address of copy is also equal to this exact same value, right? Does that make sense? And so here's what, this is the main reason why we have access to this. It's not because we're doing this. Usually I was showing you this goofy thing. But in reality, you don't need to use the pointer to access the objects because it's implied. I'm just showing you how it's used. In this case, we'll just check if this is equal to the address of copy, right? They are the same object. Does that make sense? Please let me know if it does not. We'll do a C out here just for fun. And is it RIP stream here? Let's see. Looks like we're having an RIP stream moment. So we'll just give it a second. I'll type in some comments here. Else, this is not the same object. Yeah, it looks like we're doing okay now. It usually happens once every day, and I even had this happen to me last semester. This stream happens every day, and it always happens around noon, but then we're good from there. So Aaron asks, when do we use the arrow exactly? Now, I'll show you. So the short answer of that is we're trying to access a member inside of an object pointer. And so I'll show you here. I'm going to kind of move this down. And we'll do this today when we're wrapping up this example. There's nothing stopping me from making a dynamic array pointer. Right, so in this case, we've made a pointer to the object. What is going on here? Right? And so what I can say now is I can say C is equal to new dynamic array, right? And let's go ahead and call a specific constructor, right? How about we try a different one? So here we use the default constructor. In this case, we use the copy constructor. And then in this one, we're going to do something like int size is equal to 5. And then we'll say int array 5 is equal to, let's say, 3, 4, 5, 2, 1. And then let's say we call this constructor, right, where we pass in, say, this size, right? It's this one right here, in which we pass in an address and we pass in a size. And so now that I've allocated memory into this pointer, right? What if I want to access if I want to access a function out of there, such as print array? So if I want to access print array out of C, I can't do this. Look, it even corrected it for me, which I'm really upset about that. There you go. There you go, T. Peter. There's an example of IntelliSense correcting it for me. I can't do this. Now this is saying, yeah, there we go. You see it turn red? It's because C is an address, right? And so we have two options. Option 1 is to dereference C and then call the dot operator from it. Or more easily put, we just use the arrow. Say C arrow print array. Does that make sense? So this, what the arrow does is it dereferences the address, and then it will go into that object and find that member. And so all I was doing with this is, right, this is a pointer, right? And so I'm going inside of myself, in this case, I'm going inside of this object, and then I'm referencing some members inside here. Yeah. Okay, so in this case, they're the same object, right? So we don't have to do anything. We're not going to do anything. But if they're not the same object, yes, that arrow is very useful. It's meant to be less typing. In this case, they are not the same object, so we have to do a few things, right? The first thing that we should probably do is say we should copy the size over, right? So we're going to say size is equal to the copy.size. And I know I'm repeating myself. I can do this, right? I can say this dot size equals copy.size if you're ever confused about which size we're talking about. And then I'll ask you guys a question now. The first thing I want to do is allocate some memory for the array, right? So I'll say array is equal to new int size. Now, does anyone have a problem with what I did, right? Please let me know. And I'm giving you a hint. Yes, there was something wrong with what I did. But as far as, we're concerned, this is the same stuff that we've been doing, right? Step one is for a deep copy, we have to allocate memory. And then step two is to copy over the elements one by one. But so the question I ask you then is, did this array already have memory allocated? And if it did, do you see how this is a problem? Because new returns an address, right? And so in this case, we overwrote the old address. We overwrote it. And now we've lost it, and we have a memory leak. And so the first thing we need to do is, was array already allocated? And if it was, we got to call delete on this array first. Does it make sense? Please ask if it doesn't. And notice that this is different than the copy constructor. In the copy constructor, we know that this array has not been allocated yet because we're just now creating the object, right? That's why we're calling a constructor, because this array or this object is now coming into existence. And so we know for a fact that this array has not been allocated. But here's the example up here, right? Notice at this point, when we call A equals B, A is already alive and B is also already alive. So what if A already has some memory allocated? We need to make sure that we deallocate it before we start allocating new memory into it. So from aside the fact that this is an operator that we've never seen before, this looks just like a function, right? We know how it works, and you can see what this function does, right? Please let me know if this does not make any sense, because we'll spend more time on it. But in the meantime, we're gonna wrap up some more of these guys, right? So now it's our job to do these three. So here's a hint for you guys, if you guys didn't know. For those of you who have trouble with all the scope resolution stuff, I just like to copy everything that was inside of that class. And then everything is exactly as it was, except now I'm just going to grab this scope resolution and put it in front of all of them. Just like that. And so now these functions are ready to go. And so what's this insert function going to do? It's going to be like push back, right? Now this insert is a little more involved than normal. In addition to it, it's not very efficient. So I'm just going to say this. And I'm going to ask you guys if any of you have any ideas on how we could make it more efficient. And you're welcome to say so whenever as I'm typing it up. So just keep this in mind, that this insert that I'm about to type is not very efficient, but it works. And so we need to consider that we've got some array here, right? So we're going to have some array, 3, 4, 5. And so obviously the size of this array is 3. And so now, let's say I call insert 67. So now this array needs to look like 3, 4. This is kind of like pushback, right? 5, and then 67. And the size equals 4, right? So you guys agree the first thing that we should probably do is size is now equal to size plus 1. Or rather, size plus plus, right? Now, is this okay what I'm about to do? And why or why not is this okay? So this makes sense, right? I'm just reminding you guys that this might look syntactically correct, right? Because 67 should be located at the third index, right? And so if we put 67 in size minus 1, it'll put it in the third index. Aaron says no. Yes, that's correct. Yes, Isaac, that's exactly correct. We didn't allocate any memory. Right, this array is only size 3. This array is only size 3. There's no way that we're going to put something else in there. This will probably give you a segfault. It might not, but this might give you a segfault. So the first thing we need to do is allocate some more memory, right? Now, this is not okay, right? And I'll just talk about it, right? As soon as I say array is equal to new int size, as soon as I say that, I've overwritten the old array, right? And so now I've lost everything. I've lost it all. So the first thing we need to do is, I'm going to say this is not okay. The first thing we need to do is we actually should say, we should make a brand new pointer. Say new int, new array here is now equal to this other array, right? And now we're going to kind of take some same steps here, right? Where we just copy it over, right? We're going to do a deep copy. So what do? I say for int I is equal to 0. I is less than, I'm going to say size minus 1, right? Because at this point, so assuming that this new array is empty, right? I need to copy in the 3, the 4, and the 5. I need to copy in the 3, the 4, and the 5. But this one, there's nothing to copy from this array. That makes sense, right? So we're only going to go to size minus 1. We're not going to go the full size because I had already increased it. Now, of course, you could do this differently, right? You could do the increment down here. But, you know, you're coders. It's your job to figure out all the different ways we can kind of put this together. But then I say new array located at I is equal to the array located at I. So we copy over the original elements. And then our next job is to insert that last element, right? So we're going to finally say new array. Here, I'll just copy it. Now this is okay, right? Now that's fine. So this inserts to the end. That puts in our 67, right? So now the 67 will go in there. And then now that we've saved our new array, we can delete the old array, and then we can say that this array is now equal to the new array. Is this confusing to anybody? Please let me know. But this is how an insert works. And if the size, yeah, so Red Rose asks, how can we improve it? So I will tell you. So this insert is okay, say, because assume the array is not going to have many inserts. That's fine. The benefit of this insert is that it conserves memory as much as possible, in that this dynamic array will only ever use as much memory as it needs. But every time we call an insert, we're allocating new memory, we're copying elements over, we're deallocating the old memory, and then we're I mean, that's really it, right? And so here's how we could improve it. I'm not going to do it this class, but we'll implement it in future examples. So what if I added to this class an int current index? Does anyone see where I'm going with this? In which, say, we have an array that looks like this. Let's say we allocate 6 spots to begin. And as long, and the current index will start at 0. So as long as the current index is less than the size, we can just start putting things in this array. 3. Increment current index to 1, right? Put something in there. Increment current index, put something in there. Increment current index. So notice here that in the case of this, and then the current index would be incremented to 4 here. Notice that we don't have to call any memory. We don't have to copy any arrays over because we have empty spots that are available. And so the moment that current index, yeah, let's see here. So it would only create a new array if the current index greater to equal to the size. Exactly. And you could say size times equals 2, right? You could double the size of this array and allocate 6 more. You could allocate an extra big array at the start. Exactly. And so you actually see this implementation most often, probably. This one is efficient for speed. Does that make sense? This way, we're making the speed of the program efficient, but the memory of the program is not as efficient as the speed. So there's some trade-off here. And so in this case, we're making a memory-efficient dynamic array, not a speed-efficient dynamic array. But this is our insert. Pretty disgusting, right? Oh well. Looks good to me. This makes sense, right? And you're going to have this code. Just make sure you know what's going on here, and make sure you reference this code. Not for assignment 4. You do not need this code for assignment 4. But coming up in the future, I'll even point it out. I'll say, go look at the dynamic array code because you need to make sure that you're doing your memory properly. So now we're going to do some deletes, right? Let's do some fun deletes. If we were doing the speed-efficient dynamic array, deletes would be very easy. They'd be super easy, right? And in fact, you don't have to do anything besides current index minus minus. Would you agree with that? Anybody? If we're doing a delete, well, pretend that this is just a delete with no index, and we're just going to delete the top element. We can just subtract that current index, right? But if we're doing a delete at I, int x, and I, it might be a little different. Anyway, we don't need to think about it. We'll do it in the future. So I have 2 deletes here, right? So this delete, delete at, and we're going to print that this is an index. So I've got my fun little example of code here, right? So if I say delete 2, it's going to delete this 5. If I say delete 1, it's going to delete this 4. And if I say delete 0, it's going to delete this 3 here. Okay, so we're just gonna deallocate. Well, we will deallocate, but we're going to delete the element at that location. So the first thing we should probably check for is if this index is less than 0, or if this index is greater than or equal to the size, right? Because if it's less than 0, then the index is out of bounds to the left, and if it's greater than or equal to the size, then it's out of bounds to the right. Notice that this is a Boolean, So we'll just return false here, right? You say, hey, I didn't delete anything. False. That's not correct. Else, let's do some memory acrobatics, right? Some memory allocation, deallocation acrobatics. So, the first thing I'm going to do is make a new array, right? I always put the pointer here. I'm trying to convince you guys that this is a better way of doing it. I know that I said I like this better, but this is the better way of doing it. Because if you're going to make another one, you have to specify that that's a pointer as well. So that's why I'm trying to convince you guys to do that instead. Though the compiler will not complain either way. So we'll make a new array, right? And so we'll do new int here. Are you guys okay with this? Have you ever seen that used before? This is an operator that returns a value, right? And this is called the pre-decrement operator, in which it will decrement the size by 1, and it will return that value. So this is the exact same as saying, you know, size minus equals 1, and then just putting the size in there. So these are exactly the same. So if this doesn't make sense to you, ask any questions that you need. Okay, but this is going to decrement our size, and it's going to allocate an array of size minus 1. So the next thing we need to do is copy stuff over, right? And the way that I like to do this, you know, we have our array. And I'm going to make the array a little bit bigger. So let's say that I'm deleting, this is the new array, right? This is our new array. And this is our original array. If I'm going to delete this one, and put an X there. Sorry, folks. Say I'm deleting this 5. The first thing I want to do is copy over these elements, right? And so from 3 to 4 to 5, I'll copy. And then this one is the bad index, right? We don't want to copy this one. And so if I want to do that, this is how I do that. I'll just say for int I is equal to 0. I is less than, let's say, the index. Does that make sense? If index here is 4 or 3, then we'll do 0, 1, and 2. So I is less than that index. And then we'll say I++. And we'll say new array at I is now equal to the array at I. So this is the first half. Now notice if we're deleting at 0, I will not be less than 0. So everything will work good, right? So then we'll do the latter part. And so now we need to copy in the 7 and the 8, right? And so this index is going to be the -1 location here. So in order to do that, I'm just going to copy my for loop, but I'm going to make some edits. In this case, we'll start at index +1, right? That makes sense? In which we're going to start at this index +1. So we'll be located at index +1. We'll say I is less than the new size. No, size +1. Because we're going to want to access this element, right? And we already decremented our size. And so we have to make sure that we get there. So that's why I'm doing size +1. And then I'm going to say new array I -1 is equal to the array located at I, right? So in this case, if we put in our favorite index values, 1, 2, 3, 4, and this one is 4, and this one's 5, right? So I'm going to say new array located at 3 is equal to the array located at 4. So the 7, and I'll say new array located at 4 is equal to array located at 5, and you get your 8, 8. That makes sense, right? So we'll allocate that smaller array. We'll copy over the first part. We'll copy over the latter part. Both of these for loops have a chance of not executing at all if it's at the end or if it's at the start. And then the last thing we'll do is we'll delete our old array, right? So we're going to get rid of this one, say goodbye. And then we're going to say array is now equal to the new array. Same stuff as before, right? We did that up here. Delete array, array is equal to the new array. So does that delete at make sense? I hope it does. Let me know if it doesn't. And finally, we're going to do this delete first found function, and then we're going to play with it in main. Okay, we're going to play with our class to make sure everything works. We're going to run valgrind to make sure we have no memory leaks. And then we'll kind of be done with this memory heavy coding that we've been staring at the computer for the past 2 weeks. And I applaud you guys for hanging in there and doing your best, because pointers are so much fun, I know. So, what's this delete first found? Let me grab my array examples up here. All right, we got some question here. Would we also have to delete new array after equating array equals new array? This is a good question. So just remember, we're working with addresses here. We're working with, yeah. You're kind of getting it, right? We're working with addresses here. And so array should always have, an address in it. But it should only ever have one address in it. And so here we make a second address, and so now we're playing with two of them, and we have one too many. And so we'll delete one of them, and then we'll just pass this address over to this one. And in fact, when we pass this bracket, right, we go out of scope. And then new array is no longer accessible. If it makes you feel better, you could do this to avoid an alias. But remember that new array is going to go out of scope here. So there's almost no point to do this because it's just going to go out of scope anyway. Does that make sense? But yeah, I mean, these are the things that kind of mess with your head with the pointers, right? But yeah, so step 3 here, we'll include that kind of thing. Just since we're fresh at pointers. And we don't want to be confused. So the constructor is okay. The equals operator is fine. Copy constructor is fine. This one goes out of scope, right? But if you wanted to, array equals null pointer. Yeah, there's no point, right? But yeah, exactly. He says that helped explain, right? That helped explain, right? So there's no point to do it, but it helps, right? We want to make sure that we don't have any dangling pointers. So we'll add them in there. Why not? But we could say no point, right? So that all makes sense. So this delete first found is going to be really easy. Let's say I call delete 5. It's going to delete the first 5 that it finds in this array. So in this case, let me add another thing here. Maybe not a 5, but a 4. So the resulting array of this will be The resulting array of this will be 3, 4, and then it found this 5, so then it'll delete it, and then it didn't find this 5 because it wasn't the first one that it found. Does that make sense? So we'll just find the first 5 that it finds, and then we'll delete it. And then if I call delete first found 7, this function will return false, right? Because there's no 7 in that array. So this one's really easy, and so we'll just quickly do it. So we'll do a for loop, right? For int I is equal to 0. I is less than the size of this array, I++. We'll say if the array at I is equal to this value x, right? If this element is equal to this parameter, then we found it, right? And we started from the bottom going upwards. So this will have been the first time that we found it. Let's return delete at I. Does anyone have a problem with this code? Is it confusing? Recall this is a member function, right? So we can call it from within the object, right? And we already wrote all this code to do the deallocation and the... Yeah, we already wrote this nasty code to delete the index, right? So why should we do it again? Oh, I forgot one thing here, right? If we did it, then we should return true. My mistake, everybody. I make mistakes, in case you didn't know. So we'll return true in this case, right? Because we were able to delete that value. And then this function is guaranteed to return here, at least, but it doesn't hurt to put that there either. And so in this case, this will return true always, right? It'll just delete that element at the index that it found it. But otherwise, if we don't return, then we'll return false at the end, right? Because we'll have gone through the entire array. This if statement will never will have evaluated to true. Then the function would have never returned this. And it would have gone through the entire for loop, and it would just return false at the end. Say, hey, I didn't find number 7. So that's that. And that's it for this. We basically made a vector class. Except this is only for ints, right? This is only for integers. And notice I put that, right? So what we made here was a vector int, right? That's what we made. That's exactly what we made. For insert, do we return 0? For insert, I made it a void function. So in this case, we don't have to return anything at all because I'm always guaranteed to insert at least one thing. There's a few things I want to make sure. The array gets initialized to null pointer here, and that's fine. And if we call insert here, yeah, it should be all good. No worries. All right, you ready to see this thing work? I am. Let's do it. So here we're making a bunch of arrays, right? So let's do this instead. Let's have B copy C. Oh, there's one thing I want to do here. Let's do the print array. I'm not going to do it at the bottom. And I'm also not going to do it in front of you. You guys know what this thing does, right? If you don't know what it does, then try to think about it real quick. I got to fix my brackets here. Yeah, I do. I got to fix my brackets. Right. So this void print array just makes a string. It adds all the elements to it. It'll put a comma there. At the end, it puts this thing, and then it prints it. Okay, it's just a print. It's just a print function. So, why is this? Can anyone help me fix this? This is a good question. Why is this yelling at me? And how do we fix it? I want to see if we've learned anything about pointers. Give you a few more seconds. I should get some Jeopardy music playing up in here. Okay, going once. Going twice. Dynamics, this array here is a pointer, right? So what am I passing? I'm passing an array. I'm passing an address, right? I'm passing an address. Yes, he is pointer to an object. I'm passing an address. How do I make this not an address, right? We have to dereference it. Does anyone have a problem with that? Please let me know if you do. C is an address, so we have to dereference it. Yep. We have to dereference it. So now it works. And so now I'm going to copy over some main code. Well, might as well. Let's not do that. But I am going to copy a cout statement. We'll do it this way instead. I'll copy this stuff over. And then we can even do this. We'll even do that. Here, look, it's yelling at me, right? Because C is a pointer, right? So we got to dereference it. How about we just use the arrow? Does that make sense? So look, we're just going to look at these elements. Let's look at the arrays first before we do anything. And then we'll come back to this stuff down here. I haven't even loaded up MOBA. It's been so long since we've been on Sally. We've been coding up this huge vector class. I'm going to have to do my zoom-ins and everything. Wow, I might as well get started now. Super concentration. Is that size big enough? I don't think it is. We need to keep going. We need to go deeper. All right. CD to the test directory. Side test. We can make a makefile real quick. Let's make a makefile just to show you how I fixed it. So all I have to do is type all up here, and then I have to tab. Now, guess what? VS Code is super obnoxious. I don't know how to fix this yet. I'm sure I can figure it out. But when I type tab here, it actually puts in 4 spaces. 1, 2, 3, 4 spaces. The makefile does not like that. It does not like that. So you know what I do instead? I come to Notepad++. Now this is a great thing to show you guys. If you have Notepad++ and you go to View, and you can go to Show Symbol, and say you don't have Show All Characters. Now it looks like a normal text file, right? But in fact, if you go in View, Show Symbol, Show All Characters, it gives symbols to these things. So you see this CRLF. This means Character Return Line Feed. What is this thing? This is the \n. That's an n line. That's an n line character. And then notice here that this is 1, 2, 3, 4 spaces. This is a tab. So I can see that this is a tab character here. So notice that I have my makefile. I called this dyn array. So I'll just say dyn array. Save that. And now we'll load it all onto Sally. Let me just save this. I don't think I'm in the right spot. And recall that Windows doesn't like you to save make files, probably because it uses them in some sense. So I'll just change the name when we get there on Sally. So dynamic array goes in there, makefile.text goes in there. I'm going to rename this makefile to be just makefile. And then we'll clear, and then I'll type make. And it worked, okay? That's how assignment 4 works, right? You type make, and then you can see it kind of spits out all the compiling that it's doing. And like I said, it's not our job to learn makefiles in this class, so I'm not necessarily going to try to explain what this all is doing. You can do Google if you'd like. But I'm sorry that we're not going to spend time doing that, because we have so much more stuff to learn. So now if I run a ./a.out, let's just check to see if this is correct. So here we're in main. Dynamic array A, right? This was made with the default constructor. What does the default constructor do? The default constructor initializes array to null pointer and size to 0. Does that make sense? So we can see that A is size 0 and it has nothing in it. Now we're looking at array B. How was array B created? Well, array B... Oh, guys, I have a memory... No, I don't. Never mind. Yikes. Yeah. That's fine. B was created with the copy constructor, right? Things are a little bit out of order here, but in that case, how was C created? C was created with this array that we passed in as a value, right? We passed in that address and the size. And so C is equal to this array. Let's see if that's correct. C is equal to 3, 4, 5, 2, 1. And then we used B. We used the copy constructor from B to make B using C. And so, in fact, they are the same, right? So we'll see that B is also 3, 4, 5, 2, 1. So now let's do some operations. Let's insert some stuff to A. Say A dot insert. Let's do a 5. A dot insert 67. A dot insert 1947. And then let's go ahead and do a print A. So what did I do? I called insert 5 times. Notice how the size incremented every time. And we've got our elements in there, right? We knew that this would work this way, right? And then we can do some deletes. Let's delete from B. So let's do a few things. Let's do B delete at 0. And then let's just print B. And then let's also do C. Now I have to use the arrow here, right? Because C is a pointer. Let's go ahead and delete this 5 value. So we'll delete first found 5. And then we'll print our C array. Super exciting. The most exciting part of class, I might... Oh, man, JP, why'd you do that? Oh, where did I put it? Okay, come back. Oh, man. What a mess. All right. I'll just type make, right? /. So notice that on the B array here, right? On the B array, what did we call? I called delete at 0. So we should have deleted this element here, right? We should have deleted the 3. And it looks like this array is missing 3. And then what did I call for C? I said delete first found number 5. And it looks like the first found number 5 is in the middle here. And so you'll see that we've got a 3, 4, and then 2, 1. So that worked as well. So now we're going to do 2 more things, and then we'll wrap up class for the day because I don't have time to do anything else. We're not going to do the assignment. Why not? Let's do this. Let's say A is equal to B. And then we'll call A print array. This would probably be a good time to do that cool trick that I learned, but we're not going to. So we'll say A is equal to B. So A will become equal to B. And then we'll say A is equal to A. And we should see an annoying print statement here, right? This is the same object. That's what we should see. Now delete that, and that will wrap up our example for today. So let's go ahead and just make sure that everything works as I said it would, and I'm not a liar. Today we had very minimal mistakes. Recall that these are returning Boolean values, right? So I could say if delete at 0, right? I could do that if I wanted to, but I'm not going to. I'm just calling delete at as it is. So we loaded it here. Let's do a make. I got impatient there. And so what do we do here? We said at this line, we said A is equal to B. So B is 4521. And we've got A is now 4521. Recall that A has its own memory, right? It's not the same address that B has. And then finally we see this is the same object, right? And why is that? Because I said A equals A. And when we look inside that operator overload, we say this is equal to the address of the copy. So that all worked pretty nicely, don't you think? I know this code gets kind of disgusting, right? But hopefully there was nothing that confused you guys too bad. Now would be a great time to ask any questions that you want. You guys could totally use this class, right? The next time you're doing homework, you could probably use this in assignment 4. Except you'd probably add one function that would be like int. I mean, don't do it. Use a vector. Use a vector, but you could say like get element at and then int index, right? And what would this do? This one's super simple. Right, you would just return array I, as long as, what is it not like? What do you not like about this? Anyway, you know what I'm trying to say, right? I'll have to figure this out. Something is not correct here, but what does this do? This just returns, this is like your brackets, right? This will just return an element at that location. Yeah, I don't know what I did there. Let's see. Seabase says, what are the files we have to submit for assignment 4? Just the 2 of them. So it would be mastermind.cpp and main.cpp. Just those 2. And yeah, Peter, go ahead. We can ask those questions. I don't mind. And as I was saying, right, you could just make this a string. If you wanted to use it in assignment 4, right, you could just make this a string. And there you have a string array. Let's not do it that way. All right, Isaac says I can do this. Let me try this. All right, Isaac, you're a lifesaver. You're amazing. Thank you so much for that. You've made me so happy. I've been doing that for 2.5 semesters now. You're amazing. Thank you so much for that. Yeah, if you guys have any, what's that guy's name? Ty Cruz or whatever, Lamborghini, right? Here in my garage, Knowledge. If you guys have any knowledge, you're allowed to drop that on me because I definitely need more of it. That's for sure. Oh, we're asking about time complexity here. Woo! Peter is ahead of the curve. All right. Let's look at this. What's the time complexity of our insert function? All right, we got a real computer scientist here. So, if you notice, we'll just kind of talk about it, yeah. N would be the size of our array. And so every time we do an insert, we're doing almost n operations, right? In which this for loop iterates about n times. So this for loop goes through about n times, and so we do n operations. And so for every insert, we do n operations. And so that would be O of n time yes. Now, in the case up here, if we had an current index, and we did that kind of speed-efficient array, the time complexity for best case scenario would be O of 1, because we would do one operation with no for loop, right? We would just say array at this index is equal to this element. But in the worst case scenario, it would be O of n, right? And that's the case when we run out of space and we have to allocate more space. And so this array that we're talking about right now, it's O of 1 like 99% of the time, but it's O of n 1% of the time. Does that answer your question? For those of you who don't know what you're talking about, don't worry. You will learn about that very soon. Not in this class, but you will learn about that very soon. And that's my spiel. So if you guys have any more questions, type them in now. Otherwise, you're welcome to go. Thank you for coming to the stream today. That's our... that makes sense, I think. Yeah. Yeah, you'll learn a lot more about that, and it's about counting for loops. So anyway. Oh, Seabase's dropping more knowledge on me here. I'm gonna like copy paste this thing here in my notes. Yep, thanks guys. Free to go. Happy Wednesday. Hope you have a great weekend. Send me messages about the assignment if you need. I'm here to help. I'm here to help. We didn't even do any notes today. That's amazing. Put that there. All right, guys. Office hours very soon. I'll catch you later. Goodbye.